Alright, so now we're talking about buoyancy. Buoyancy is the upward force on an object. It works against the force of gravity and is produced by the surrounding fluid in which it is fully or partially immersed. So, due to the pressure distance of the fluid between the top and the bottom of the object. So, we're going to do a lab that's going to help us understand buoyancy a little bit better. But the net upward buoyancy force is equal to the magnitude of the weight of the fluid displaced by the body, enabling objects to float or at least seem lighter. So buoyancy is important for boats, ships, hot air balloons, and airships. The one thing to look at here is in this picture where you have kind of the boat in comparison to the metal, the amount of iron there in that picture is the same. So it kind of depends on the shape and how much water it actually displaces. So the kind of boat-shaped piece of iron displaces a lot more liquid than the solid mass of iron. And because of this, it has a larger buoyant force, which allows it to float. Okay? Compressibility is also a measure of the relative volume change of a fluid as a response to pressure changes. So you have a larger picture of the diagram there in the lower left corner. But it shows there about how pressure changes depending upon how much we've compressed them. Alright? This all relates to the particle model of matter, where the particle model of matter is a scientific description of the tiny particles that make up all things. All substances are made up of tiny particles, or so the particle model of matter states. All particles in a pure substance are the same. So different pure substances are made of different particles. All particles have spaces between them, so all the particles are always in motion. The speed of the particles increases or decreases when the temperature increases or decreases. So again, just to put that in a different perspective, as temperature increases, the speed of the particles also increases, and when temperature decreases, the particles decrease. The speed of the particles decrease, I mean. So the particles in a substance are attracted to one another, and the strength of the attraction depends on the type of particle. Now, let's talk about temperature with the particle model of matter. Temperature indicates the average energy or speed of the particles in motion of its substance. So you need to keep in mind that this is the average speed or energy. It's not of any one particular particle, it's the average of it all together. So an increase in heat makes the particles of a substance move faster, and when the heat is lost from a substance, the particles will move slower. When two substances of different particles are mixed together, the smaller particles of the one will fill in the spaces between the larger particles of the other substance. When the particles of a solute are attracted to the particles of a solvent, dissolving occurs. The solute then dissolves the solvent. So dissolving. Water is called the universal solvent because it can dissolve so many materials. 97% of the water in the Earth's ocean, 97% of water is on the Earth's ocean. 2% is frozen, and about only 0.5% is usable, or potable water, right? This is something we discussed in our very first unit. And even this has materials already dissolved in it that can become harmful. So this is why we talked about things like distilling and reverse osmosis. So the rate of dissolving is affected, it all depends on the solute and the solvent. So the speed at which the solute dissolves the solvent is called the rate of dissolving, and it can be affected by agitation, so stirring it or shaking it, the temperature, as well as the surface area of a solute exposed to the solvent. We'll talk about this all in a bit. The next video is going to be on matter and changes of state.